Hello ladies, gents, and everyones. It is Thursday, May 13th, and we're here to talk about this week's space and astronomy news. Over on Mars, the Ingenuity helicopter completed its 5th flight last week, the final flight of its original planned mission. However, now that the technology demonstration is over, the mission has been extended into a new operations demo phase. This phase is going to include less frequent flights that will be scheduled not to interfere with Perseverance's science mission, but also riskier maneuvers, more high-precision maneuvering, and greater use of its aerial observational scouting capabilities. In this 5th flight, Ingenuity actually left the Wright brothers field and flew to a new airfield a few hundred feet to the south, so this was its first one-way trip. During the flight, it achieved a new record altitude of 10 meters, which, if you've ever jumped off a 10-meter tower, that's pretty high. The team is going to assess these flight operations in the operations demo phase after another 30 sols, and flights are expected to not continue at any point past August of this year. Now, while Ingenuity's been getting up to all that, Perseverance has started doing science with its robotic arm. This arm contains an abrader that can be used to expose the interior structure and composition of rocks. It also contains instruments called Pixel and Sherlock and the camera Watson. So it's really exciting to get this robotic arm up and doing science like it's supposed to. Speaking of Mars, you may have seen some claims floating around the internet based on a new paper published recently in the Advances in Microbiology that claims a detection of possible fungus on Mars. The images reveal structures that they claim to be similar to those puffball type mushrooms here on Earth, but of course in the Martian landscape. Now, this type of extraordinary claim requires extraordinary evidence, and so far that is lacking. The extent of peer review that this article underwent is not really clear, and one of the main scientists behind it is actually a neuropsychologist who has a long history of making rather outlandish, unsupported claims about life on Mars. In addition, there exist other simpler and better explanations for these structures, aka their rocks. And so, unfortunately, as exciting as it would be, I don't think that there is any merit to this claim at this point. I don't find it to be a credible claim of mushrooms on Mars. So, ignore the sensational headlines. And speaking of sensational headlines, last week all eyes were on the 20-ton rocket stage from China's Long March 5B rocket that was in an uncontrolled re-entry. And after a lot of conversation, observation, and tracking, it finally mostly burned up above the Indian Ocean on Saturday. Now, the reason this happened is that this version of the Long March rocket was redesigned to be able to carry more payload, and that required getting rid of the maneuvering capability for the second stage that could allow for a controlled reentry, aka making sure that it lands somewhere uninhabited, which is not present now on this current version of the rocket. This is the second time this version has been used. It was also used last May, and a similar thing happened, and in that case, the debris landed in West Africa. And there are 2 more launches planned in 2022 of this variant of the Long March, and so expect this to happen again. Now, these 2 uncontrolled re-entries were the largest such uncontrolled re-entry in the past 30 years. So basically, since the 90s, there's been kind of an international consensus about not letting these sort of very large objects land where they may, because they could be dangerous to property or people. And so generally anything larger than 5 tons should have some sort of controlled re-entry. However, there is not any international law regarding this. And so while some have been criticizing China for this somewhat, in their minds, irresponsible re-entry, including NASA, China is saying, well, we are in perfect accordance with international law, which they are, and it seems that they do definitely plan to do this again in 2022. So that's the status of the Long March 5B situation, and definitely expect to hear about this again in 2022 with those next launches. So we've talked about astrometry on this channel before, so this is basically the precise measurement of positions and velocities of stars. And one thing that's really exciting about this is that it could potentially be used to detect planets, because as a planet and a star orbit one another, these small motions induced in the star might be visible. Now, this sort of astrometric method has been confirmed by detecting planets that we already knew existed. However, it has never been used to discover a new planet as of now. This is expected to change drastically once the full Gaia mission releases its data in the next few years, but as of now, it's never been used to successfully discover a new planet. But now a team of astronomers from the United States Naval Observatory think that they might have a lead on one from astrometry. By combining observations from a variety of sources, these astronomers identified a bright solar twin star called δPav that has an anomalous velocity that could be due to a planet. They found a pretty high significance for this velocity, and if there was a planet responsible for it, it would be a long-period giant planet similar to our Jupiter. So this is really exciting, and if confirmed, would be the first astrometric discovery of a planet. Voyager 1 is a NASA mission that launched back in 1977 and has been going strong ever since. It entered the interstellar medium back in 2012 and is currently over 150 AU from us. This basically makes the Voyager 1 an in situ probe of the interstellar medium. And one cool thing that it's been able to do is measure the density of the interstellar medium by these infrequent shock waves that cause the medium to oscillate at a certain frequency. However, these only happen about once a year, and so we're really not getting a full picture of the density as it traveled. But a new paper just published in Nature Astronomy found a new method to basically measure the density in a more continuous manner from the Voyager 1 data by looking at these much smaller scale oscillation events that are almost continually happening. So this can give us a much more complete map of what the density of the interstellar medium around the sun actually looks like. Based on the measurements from this new method, the electron density around Voyager 1 started to rise in about 2013 and increased all the way up until about 2015, an actual 40-fold increase in the density, and then it's been roughly constant up until the end of the data that they have, which is early 2020. So this is a really cool way to use existing data to further our understanding of the galaxy and our sun's place in it. Even so, old data is great, but new data is even better. So astronomers are very, very excited about the upcoming launch of the James Webb Space Telescope, which is basically the kind of flagship successor to Hubble. However, this mission has been plagued with numerous cost overruns and delays, so it's like a very much knock on wood situation. But good news is that it recently passed a very big milestone in that it did a full unfolding of its primary mirror for the last time here on Earth. So this is a 6.5 meter mirror that basically has to be folded up for launching and traveling, and then has to unfold on its own in space over 1 million kilometers from the Earth and close to a month after launch. So it really needs to go right. So in this test, they basically fully mimicked this situation of how the mirror is expected to unfold in space, including special equipment to simulate a zero gravity environment for the telescope itself. It was successful, and so this is great news for JWST, and that means that they are hopefully on track for that October 31st launch. Well, that's all I have for you this week. Thanks so much for watching. I hope you enjoyed, and I hope you will join us again next week. Have a good one. Bye.